Hello everyone, I'm Ksenia Dmitrieva and I will be teaching the Defensive Programming for JavaScript and HTML5 course at AppSec Europe on June 29, 2016 in Rome, Italy. In this course, we will look at the security risk landscape of modern web applications that use HTML5 technologies such as cross-origin resource sharing, WebSockets, and web messaging, and heavy JavaScript front ends using frameworks like AngularJS. We discuss common vulnerabilities, look at sample attack scenarios, and then demonstrate mitigation strategies and security best practices for each technology. We will also have a section discussing specifics of server-side JavaScript frameworks, such as Node and Express, and their security risks. This course will be helpful to front-end as well as back-end developers using JavaScript and strive to create secure web applications. As for me, I'm an associate principal consultant at Cigital, and I've been doing security for over 6 years now. In these years, I have done a wide range of security activities such as penetration testing, code review, architecture analysis, training, and research. Prior to turning to security, I was a software developer. Let me give you a sneak peek into one of the topics we will be covering in the class, defensive programming in AngularJS. AngularJS is a model view controller front-end JavaScript framework that adapts and extends traditional HTML to present dynamic content through two-way data binding. That allows for automatic synchronization of models and views. Let's look at some of the important components of AngularJS. First of all, that's data binding. It allows to automatically synchronize the data between the model and the view components. Angular templates are written with HTML that contains Angular-specific elements and attributes. Then Angular combines the template with the information from the model and the controller to render the dynamic view that the user sees in the browser. This is done using the two-way data binding, client templates, and the REST API-based backends. Angular routing features enable client-driven loading of multiple views and controllers, allowing applications to interpret URLs and deep links in Angular JavaScript. This helps to structure the application's files and modules. All of these properties allow us to create single-page applications with AngularJS. In a single-page application, all the necessary code, the HTML, the JavaScript, the CSS, is retrieved from a single page load, and additional information is then loaded via AJAX. Thus, Angular applies an MVC model to a client-side web application part. So the view displays the output, the models are primary objects that maintain state, and controllers manage communication between the views and the models and apply business logic when necessary. One of the well-known security features of the Angular framework is automatic contextual output encoding. Any element in an Angular template that is bound with a variable through ngbind directive will be automatically encoded according to its context, such as HTML element, HTML attribute, or URL. This will result in a value that is safe for displaying in that context without encoding it on the server side. This Angular feature automatically prevents a wide range of process scripting attacks. In this example, we have the welcome variable within our HTML controller that contains some HTML tags, and it is bound using ngbind directive. As a result, every less than and greater than character will be automatically replaced with an according HTML entity, and the whole string will be interpreted as text by the browser and not evaluated as HTML code. In other situations, we actually need to display user-supplied HTML input, so we can't use ngbind. For this purpose, Angular has implemented strict contextual escaping, which displays a safe subset of HTML tags, even if they are provided by the user. If user input is bound via ngbind HTML directive, and it contains malicious tags such as script, on error, on mouse over, on click, SCE will automatically pass it through ngSanitize module, which only displays whitelisted tags such as bold or italics. For example, when using ngbind HTML for the same input, only the EM tag will pass through the sanitization, and the style attribute as well as onMouseOver handler will be removed. However, there are a few things that developers need to know about strict contextual escaping, or SCE. SCE is enabled by default in Angular version 1.2 and later. If you use AngularJS version prior to 1.2, you need to explicitly enable SCE when defining the Angular application. In AngularJS versions 1.2 and greater, SCE can also be explicitly disabled, so we need to make sure SCE is not disabled. To employ strict contextual encode and escaping and render content as HTML, we must use ngbind HTML directive in the template. Also, SCE can be explicitly disabled for particular element with the trust as functions. This function has also aliases for some contexts, such as trust as HTML. Sending values containing untrusted user input to SCE trust as HTML will lead to cross-site scripting. For example, if we use SCE trust as HTML function when assigning our welcome variable and also bind it with ngbind HTML, all the HTML tags will be processed by the browser as is. And if a user placed malicious JavaScript, such as onMouseOver event, this JavaScript will actually be executed. Now let's look at a quick demo. When we are using ngbind, Angular performs automatic contextual encoding of the text. In this case, we are setting the welcome variable to this HTML markup. Let's see what happens in the browser. Here we can see the whole string displayed as is without any of the markup applied to it. Let's look at the source code. We can see that all less than and greater than elements are actually replaced by HTML entities. This is not the behavior that we always want. Sometimes developers actually want some of the HTML markup to be applied to the string. In this case, we're going to use ngbind HTML directive. Now we can see that some of the markup was applied to the string, but not all of it. Let's look at the source code. We can see that only the EM tag was applied, and all the other tags like the style attribute and onMouseOver event handler were actually stripped from the string. This is because the strict contextual escaping applied by Angular only leaves a safe subset of HTML tags. What if we actually want some of the style to be applied to the string? Well, we can use the SCE trust as HTML function. Now we can see that all of the HTML markup was applied. However, it also applied the onMouseOver event handler that contained some malicious JavaScript. You can see that using SCE trust as HTML function can be extremely dangerous with untrusted input because it can lead to cross-site scripting. As you can see, even when using new frameworks such as Angular, your application may still be vulnerable to cross-site scripting. And what about server-side attacks, such as command injections or malicious code execution? What is the best way to configure your cross-origin resource sharing policy to protect your application from data leakage and functionality exploits? How do you protect your application from these risks if it is written in Node.js and Express? If you want to know the answers to these questions, I encourage you to come to AppSec Europe in June 2016 and attend my training, Defensive Programming in JavaScript and HTML5. And then you should definitely stay for AppSec Europe conference from June 30th to July 1st, where you can hear the best of the best speakers in the security community. See you there!